this, right? Just now imagine if there is a two magnet like this. Okay, if I bring two magnets like here, it will automatically get attracted, right? With the opposite direction, it will automatically get attracted. If I bring the same, like same poles, same side of magnets near to it, we can't move for a particular distance. It will automatically get disturbed. It will automatically get diverted, right? What it means when we bring the opposite side, when it was coming to the particular distance, it is getting automatically attracted. When it was same pole, when it was coming to the particular distance, it was automatically getting deviated, right? It means that around that material, around the magnet material, there is some place, okay, where they will have their property, that is called their forces, that is called their field. See, we will spread the positivity, negativity around us, right? So there will be the circle for everything. Okay. So for a material, there will be the place around it. Until then, they will have their properties. Okay. So that is called as an electric field in terms of electric charge. The same how we are doing for the magnetic material will applicable for the electric material. Electric charges also. Like if I take positive charge, if I bring together, automatically it will get deviated for a particular distance. Okay. If I bring negative charge and positive charge, it will get automatically attracted when it was coming to the particular distance, right? So that place is called as an electric field. Okay. So we can say area in which the charge can exert its whole property or its force. Okay. So the formula for the electric field is equal to, is written as F is equal to Q times E. Ma'am, you said we are going to write only the formula for electric field. Why you are writing the formula for force? See, I said already, we are we can only speak about the electric force when there is a force around it, right? I said if there is a material, there will be the region around where they can exert their force, where they can exert their characters, right? So that can be calculated only by using their forces. We can determine only by, see, if you are taking the magnet, if the magnet is not working, if you bring anything near to it, if it is same opposite, it is not reacting properly, it means that it doesn't have the force, right? That's why we are deriving the formula for the electric field by using the force, not directly. Keep it in mind. Okay. So this is the electric force. Okay. So normal force, Coulomb force is that one. Attraction, repulsion. This is the force in the charge, electric force around the material. Okay. So this is the electric force is equal to charge times electric field. From this we can write electric field is equal to F over Q. Okay. This is the formula for electric field. And here, when you are studying this lesson, okay, I said already we will study about the point source, right? Here, we will speak about two things. One is test charge, another one is a source charge, okay? Now, if there is a charge, okay, if I want to check it, okay, that charge is called as a source charge. By using what I am checking, that charge is called as a test charge. Okay, just keep this in mind. Sometimes they are asking this question in a 1 mark. So what does mean by test charge? What does mean by source charge? Source charge, which is creating the electric field. Test charge is nothing but which is used to test the source charge. Okay. And in the assertion reasoning also you may get the question, source charge, electric charge, both will give the electric field, and test charge is used to check the source charge. Assertion reasoning, what you are going to answer? Of course both are same. Assertion reasoning, both are same. Okay. Because test charge also is a charge, it can produce the electric force. So both can produce the electric force, but one is producing and another one is used for testing. Okay, that's it. No. The next important thing in this one is like electric field, how we are calculating. The same thing. See, don't get confused with this lesson because we are using so many formulas here. In the first Coulomb's law, F is equal K Q1 Q2 over R square. This is the first thing, right? So after this, I just told us how to write the vector notation, right? So this is the basic thing. Just keep this in mind. Okay. Up after this, the important thing is this one. Okay. So electric field E is equal to F over Q. Okay. So here, if there is a charge, see, if I'm going to take the first one, if I'm going to calculate the value of E1, okay, E1 is an electric field because of the charge Q1. Okay. So E is equal to F over Q1, right? Okay, there will be the test charge here also. Like this is the test charge. The down one is always the test charge. Keep it in mind. Which one we are using to test it. Okay, so E is equal to F over Q naught. You can write it in the simple way also, or you can write it in the formally E is equal to F over Q also. You can write it. Okay, the thing is here the force again we are going to use the same formula. So if I'm going to talk for the two charges, if there is a test charge q and the source charge is q1, okay, how we are going to write the f is equal to k, of course q1 is q1, q2 is the test charge, it is q or q naught, we can take it, divided by the distance is r. So I'm just writing R1 square. Here I mentioned R1 square. So this is the value of EF. If I want to calculate the value of E is equal to F divided by Q. The same thing. So I can write A K Q1 Q divided by R1 square divided by Q. So it will get cancelled, right? So what will be the formula? E is equal K Q1 over R1 square. Okay. So just remember, in the case of calculating F, there will be 2Q. Okay, K is equal Q1, Q2 divided by R square. In the case of calculating E, there will be only one Q. Okay, so it is K Q1 divided by R square. This Q1 is not a testing charge, it is a source charge for which one we are checking. Okay, just remember these 2 points. Okay. Yes. Now, the physical significance, why we need it. Okay. So, what is the physical significance of these electric field? Of course, by using the electric field, what we can do? We can check how much, how far they are exhibiting their forces. Okay. And we can check, how independent it is working, how the charge is working. Everything we can check by using the electric field, right? So these are all the basic things you have to know. Now I'm moving for the question part. Okay. Yes. This is one of the past paper question, and that too it is very recent past paper question, 2023 past paper question. So electron experiences a force. Okay, as I said already, first write the given detail. The force is given, F is equal to 1.6 times 10 to the power negative 16 Newton, right? And in an electric field E, what is the value of electric field E? That's it. This is the detail they given. This is the detail they want. Okay. So now, how to calculate the electric field? E is equal to F over Q, right? So what is the value of Q we are going to use here? There is no value for Q here. But read the question. It was mentioned that it is an electron, right? So what will be the value of electron there? It will be negative 1.6 times 10 to the power negative 19. Make sure in the place of electron, you are using negative, because whenever you are getting electron, you have to use negative. Okay. So if it is mentioned only the charge, then you can use 1.6. Okay. So here we are going to divide this and we will get the value of F. Okay. So this is how we have to, this is a simple question, but only complicated thing is they didn't mention about, they didn't talk about the value of charges. So you have to read the question, and from the question you have to take the value of Q. Okay, that is the thing. And this is the question, the same 2023 question. And this is a quite complicated question. Yeah. So the magnitude of electric field due to the point charge of object at a distance of 4 meters is 9 Newton Coulomb. From the same charge, the object electric field of magnitude 16 Newton per Coulomb will be at a distance of. Okay, so we have to calculate the value of distance. They give the value of electric field. Okay, so first write the details what they given. Okay, first here we have two electric field. They are talking about two things, right? So just write in the easy way. First I'm writing the first one, E1. Okay, E1 is equal to 9 Newton per Coulomb. Okay, this is the first one they given. For particular distance, which means that R is equal to 4 meters. This is what they give. Now, what they want from us, the value of E2 is equal to 60 Newton per Coulomb. What is the value of R? This is what they want, right? Yes, right? And it was mentioned that the same charge, which means that the Q is same. We don't know what is the charge, but it was mentioned that it is same, right? Q is same. Now, do one thing. First, we have a value of E and R, right? Is it possible to calculate the value of Q by using this? Then we can find easily the value of R. Yes. See, because we know E is equal to K Q over R square, right? It is correct or no? Yes, right? From I said already, like E is equal to F over Q, right? So for the F, we are going to use K, Q1, Q2 over R square. Again, we will cancel, right? So the same way we are getting this. Now, I'm going to apply these two values here. So what will happen? E is equal to 9, right? So 9 is equal to K, right? And then value of Q we are going to calculate divided by R is 4 square, right? So we know the value of K, right? K is equal to 1 over 4 pi epsilon naught. And I hope you people know that it is 9 times 10 to the power 9, right? So when you are applying the value of all the value, you will get the value of Q. Q is equal to 9 times 4 square divided by K, right? So definitely you will get the value of Q here, right? So what else? We have a value of Q. We have a value of E2. E we have, Q we have. Then we can calculate the value of R easily, right? So this is how we have to solve this question.